Hello, everybody. Hi, and
Hi.
welcome to our live solve. Oh, yes, wonderful. I just want to double check with everyone in this room. Is everyone able to hear us? If you are, please send something into chat relay. You may notice that we're using a system here which is different from many other Zooms. And the way this works is that if you have something to say, just choose to send a message to the thing that's called chat relay, and then things will appear on the screen. Yes. We have moderators here, so of course, please be reasonable. If you say things that are not so reasonable, they might not let your message through. But if you say good things, they might even give you a star. Well, let me first say a little bit of welcome. So, hi everyone. Good evening or good morning, wherever you may be. I'm Po-Shen Loh, and I am a math professor. I'm actually the guy who's behind all of this. I have to apologize, first of all, that my setup and my background look far, far worse than my co-hosts, who I'll introduce in a moment. And the reason is because I'm actually traveling on the road. I happen to be in New York City at the moment. However, also because of that, I actually have a very bad upload speed, which means that some of these, I'm still going to be working out how I can help to explain some of these questions. But in the meantime, we'll have the two of them go. And at this point, I need to say that's the special thing about this whole stream. There are some people here who are awesome. And I want to introduce them to you because they are going to be the co-stars of tonight, and they will be solving the problems live, as will I, as soon as I get my upload speed working. And so the two people are, well, let's just go by alphabetical by first name. Elena, could you maybe say hello so you can take over the screen?
Hello.
Yes, this is Elena. And I actually got to know Elena this summer because she was at the US Math Olympiad Summer Program. That's a program which has about 60 of the top US math students in high school every single year. Now, she also actually was the coach of her local middle school math team too, so she has lots of experience explaining things, and you'll see soon. She was also involved in Prime's Circle. Prime's is a program run by MIT Mathematics Department. So she's from the Boston area. We also have Pratika. Pratika, can you say something so you can take over the screen?
Hello.
Yes, this is Pratika. Pratika comes from Canada. She's in Toronto. And so she actually has also done lots of math competitions. She actually has reached honor roll in national Canadian math competitions, such as Pascal, CIMC, and Fryer. In Canada, they named their competitions after mathematicians, which is quite interesting. And she also loves solving difficult math problems. She also does things other than math too. She also plays basketball and enjoys singing and playing many musical instruments. But what we're going to do today is we're going to be playing with lots of math. And so I want to emphasize right now, this is an official collaboration with MathCounts. It's a real pleasure to work with them because MathCounts is what got me interested in math way back when I was in middle school. And with that, let's go ahead and start doing some actual problems. I will drop out until I can figure out how to improve my internet upload speed. And Elena and Pratika will take over from here.
All right, let's jump into our first problem for today. The question asks, what integer is closest to 4.7 over 2? Okay, immediately one notices that this is like an estimation problem. It's probably not that difficult to divide this out, but I wonder if there's a different way to do it. Maybe I will consider 4.7 is like kind of odd looking. So maybe I don't want to work with 4.7 directly. I see some suggestions in chat to round 4.7 to 5. This makes a lot of sense because if we divide 5 by 2, this will give us 2.5. Whereas maybe we can look at the lower bound here as well. 4 over 2 would give us 2. So we know that if we divide 4.7 by 2, this should land us somewhere in between 2 and 2.5. But this is like very clear where this rounds, because if it's less than 2.5 and it's greater than 2, this means that when we round it, it has to round to 2. So therefore, our answer for 4.7 over 2 should round to around 2. Oh, I see suggestions to do 47 over 20 as well. I like that too. I like working with integers, so that seems reasonable as well. But either way, I think you would get 2. Let's check our answer. Yeah.
Hooray! Okay, awesome. So I'll be taking the next one then. So it's asking what is the value of 10 cubed over 3 to the power 4 minus 1? So, okay, for this one, I immediately saw the denominator, and I'm like, okay, 3 to the power 4 minus 1 squared. You know what that reminds me of? Difference of squares. So I was thinking 10 cubed, 3 squared minus 1, and then 3 squared plus 1. And then I see, okay, 3 squared plus 1, 10. and I have a 10 in the top, so I can maybe cancel some things out. So I have 10 squared times 10, and then we have 9 minus 1 times 10. So the 10s cancels out, and then we're left with 100 over 8. Yes, okay, I see a lot of answers in the chat. 12.5 is our final answer. When we round this, awesome job to everyone who's typing 12.5. Okay, let's see if that is right. Yes, 12.5. Awesome job, everyone.
Amazing. All right, for our next question. What is the greatest integer value of t for which 3t is less than 260? Wow, we have a lot of similar problems here. This feels a lot like the previous problems we've done. Greatest integer value of t. I guess one thing that sticks out to me right away is that this is like really close to 240, which is a multiple of 3 that I know. 240 is equal to 80 times 3. So it's got to be slightly above 80. Actually, we are just about 20 underneath 260. And 20, well, this is 18 plus 2. So I guess we can just take 3 times 6, and then there's 2 left over. So this should give us 86. We could have just divided directly, which also works, and then we would have just taken 260 over 3, and then we take the integer part of this. But I like dividing like this, because recognizing multiples actually makes it a lot faster for me. Yeah, amazing. Yeah.
Awesome. Cool, okay. So now we have some geometry. So fun. Okay, so we have in triangle ABC, the measure of A is 40 degrees, the measure of B is 85 degrees, and we're trying to find the measure of C. Okay, so we don't really need a diagram, but you know, I'm extra, so I'm gonna add a diagram. Okay, so we have this is A, this is B, this is C, this is 40 degrees, B is 85 degrees. Okay, and yes, I see Alex says angles in a triangle all add to 180. So it is indeed 180 degrees minus 40 degrees minus 85 degrees. And this is equal to 55 degrees. So yeah, just it's the interior angle theorem in a triangle, which is very nice. So yes, 55 degrees. Let's check. Awesome.
Wonderful. All right, the next question asks, the arithmetic mean of 4, 8, 6, 9, and n is 6. What is the value of n? I suppose the best idea here is to work backwards from the definition of an arithmetic mean. When we take the arithmetic mean of a set of numbers, what we're doing is we're adding together all of the numbers in the set and then dividing by the quantity of numbers we have. So here we have 4, 8, 6, 9, and n, which gives us 5 numbers. So what this means is when we added together all of these 5 numbers and we divided by 5, we got 6. So what this tells us is that our total here should be 30. So all of these together should add up to 30. And then we can just do arithmetic to figure out what n was. Arithmetic is kind of hard, but it's okay. So initially here we had a sum of 4 plus 8 plus 6 plus 9 plus n. This gives 15. This gives 12. Okay, this is 27. So n should be 3. I guess there is also another way to do this, is when you're working with an average, we can kind of see where we go above and below the average. And when we add up all of our numbers together, like I guess the net of above and below the average should be 0. So this can give us a way to figure out our last number without having to do all of the addition and division at the same time. So the way we can do this is, numbers to remember, 4, 8, 6, 9, 4, 8, 6, 9, and our average should have been 6. And we're trying to figure out our number n. So we can also rewrite this as this was 2 below the average, this was 2 more than the average, this was 0 more than the average, and this was 3 more. So then in that case, we want all of our above and belows to add up to 0 in total. So we're some number above or below here, and we can we want all of these to add up to 0. And we can see that this is quite a bit faster because 1, we don't have to work with division, and 2, all of the numbers are really small and nice. Actually, -2 and +2 already cancel out to 0. We have a 0 here. And since this is a 3, we know that our number here, n, has to be 3 below the average, because 3 plus -3 adds up to 0. So this means that n is equal to 6 minus 3 is equal to 3, so we get the same answer in that way.
Whoa, I really like that way. I actually really like that way. That's so quick. I didn't think of that, but that was really cool. Okay.
Thank you.
Yeah. So now we're on to this next problem, number 6. So we have Calvin and Susie. They live on the same side of the street as shown. And then we have the adjacent houses have address numbers that differ by 6. We have Calvin's address number is 2021, and it's less than Susie's address number. And we're trying to find Susie's address number. Okay, that's a lot of address numbers in one problem statement, but here we have Calvin is 2021. Okay, so immediately I see, okay, this house is going to be 1, 2, 3 houses away. And since it's going to be more, it's going to be 2021, or we can like individually name them just for fun, because, you know, why not? 2027, whoever this person is, let's call them, think of a name. I'm feeling Alvin. So Alvin is 2027, so that's the middle house. And then we have 2027 plus 6, again, which is 2033. And that can be Bob's house. Okay, and lastly, Susie's house is 2033 plus 6. And finally, that's 2039. So I see a lot of people in the chat, they just immediately did 2021 plus 3 times 6, which is obviously a better way. You don't have to like list them out. You just see, okay, well, Susie's house, it's 3 houses away. So I'm going to do 3 times 6, which is 18, and then add that to the previous. So yes, your answer is 2039. Let's see if that's right. Yay. Okay, cool.
The way with adding just 3 times 6 is really sleek, but I would caution people a little bit because oftentimes in problems with arithmetic progressions, you have off by 1 errors, or maybe you add 1 time too many or 1 time too few, and it's really easy to make mistakes that way. So when you're working with adding a very small quantity of things, it might actually be better or like more efficient points-wise to add it up individually because you're much less likely to make a mistake.
Yeah, exactly. And also, I was just gonna like highlight one comment. Someone said like, can't you have like it be 2 different address numbers, or like it was a different option? Just remember that in a street, you can't have 2 people who have the same address because that would be a bit confusing, right? Imagine they're like, okay, my street address is 2027, right? And then you go to the street, you don't know which one it is. You're on the same street. But yeah, just remember that it's you have to ensure that the street numbers are different for each one. So that's why it's just strictly increasing, and it cannot decrease from there. Thanks.
Great. Okay, the next problem. The perimeter of a rectangle is 36 millimeters. What is the greatest possible area of the rectangle? Okay, well, my intuition tells me that the best rectangle area-wise when we constrain the perimeter is a square. But that seems kind of far-fetched, like it makes sense, but I don't want to pull that out of thin air. I think we should try to prove it. I do see a lot of people making this observation in chat, but it would be cool to prove it. The question is, how do we prove it? Okay, so suppose we have a rectangle, and for ease, we will just call the sides A and B, and we'll know that eventually A and B should add up to 18, which is half the perimeter. So we have a fixed sum A plus B is equal to some value. And we'll call it K for constant, because constant is spelled with a K. Okay, what else? So we are trying to maximize AB. How do we do this? I guess there is a sum that involves AB and A plus B where we can have A plus B squared is equal to A squared plus 2AB plus B squared. which I guess is like always a positive integer, but that's not incredibly cool. I guess a minus b squared. This gives us a squared minus 2ab plus b squared. That's kind of cooler, I guess, because what we have is this is a positive integer always. Oh, I guess we have the inequality called AMGM, which is a bit of a cop-out. But what it tells us is the arithmetic mean of two numbers is always greater than or equal to the square root of the product of the two numbers. And this can actually be extended to more numbers. So what we have, this is called the AMGM inequality. When we apply it here, what this means is that a plus b over 2 is greater than or equal to root of ab. And since we have a fixed a plus b, this actually just gives us the maximum bound on root ab. And this in turn gives us the bound on ab as a product. So if we have a plus b is 18 here, and this is because the perimeter is 2 times a plus b, then we get that 9 is greater than or equal to root of the product, which is the area. So AB should maximally be equal to 9 squared is equal to 81. Now, when we use an inequality, we always have to show that this is achievable. In particular, maybe one case where this would not work is if we were to have, for example, not an integer over here, and then we were asked for like integer side lengths, we would have to sort of work around this. But in this case, this is achievable, and this is when a is equal to b is equal to 9. And I think this works. This asks for a greatest possible area, so this should be AB is equal to 81.
Awesome. Yeah. Super creative. AMGM. I love AMGM. It makes life so much easier. Anyways, our next problem, number 8. So it says it requires 5 tablespoons of flour to make 15 gulab jamun. Given that there are 16 tablespoons in a cup, how many cups of flour are required to make 200 gulab jamun? Okay, fun story. I've actually had this sweet before. It's really good, so I recommend you guys try it. But yes, on to the math. So it requires 5 tablespoons of flour to make 15 of these sweets, right? So we're trying to find how much are required to make 200. Yes, I see some hype for this sweet. Just keep hyping the chat. This sweet is so good. Anyways, so we're trying to make 200 of them. So first, let's figure out how many total tablespoons we need. So if we require 5 to make 15, then we will need 200 divided by 15 times 5 tablespoons to make 15 gulab jamun. So then this would be a total of, let's simplify this, 5 and 15, this becomes 3. So this would be 200 over 3. So that's currently the amount of tablespoons. Oh, yes, I see some comments in the chat. I've never tried it from Alicia. You should try it. It's really good. So we need 200 over 3 tablespoons to make 200 gulab jamun. But it's asking us how many cups of flour we need. So that means we have to change this 200 over 3 into cups. Okay, so we know that there are 16 tablespoons in a cup. So that means to convert it, we would have to do 200 divided by 3. That's the number of tablespoons. And there's 16 tablespoons in a cup. So we have to divide this by 16. So we could just do multiply by 1 over 16 to get 200 over 48. Now I'm going to simplify this again to get, hold on, what do we divide this by? To simplify this most, I'm going to simplify it first by 4. 50 over 12. Oh, if we simplify it again, okay, 25 over 6. Cool. Okay, so 25 over 6, it's asking us as a mixed number. Okay, so we just do this. 4 is the number of times 6 goes into 25. And then we have a remainder of 1. So 1 over 6. So yeah, that's how I did it. Do you guys have any faster ways for this one? I don't know. Just curious. Is there a faster way? Because 1 over 6, I got using like conversions, but I don't think I saw one in the chat. But yeah, 1 over 6. First let's see if that's right. Yes, awesome. 4/1/6. Cool. Yes. Life story. Try this sweet. It's so good. Yeah.
Lovely. I did want to go back to, I was thinking about how to prove AMGM without just like throwing it out at everyone. I did come up with a way. So I just wanted to assert to you why it is true. The problem that we did before with the answer of 81 with AMGM. So the way this works is we do use that the square of a real number is always a positive or zero number. So consider if we take, so we have 0 is less than or equal to x minus y squared. And this is true because x minus y squared should be a non-negative number. And then if we are to expand this, we have 0 is less than or equal to x squared minus 2xy plus y squared. And actually, this is the same as x squared plus 2xy plus y squared minus 4xy. Now, this is a really cool manipulation because what this allows us to do is isolate this as the square of a number. In fact, this is x plus y squared. And we can bring this term over to the left side. So we have that this is greater than 4xy. And then from here, we can take the square root of both sides. Now, that's kind of finicky. It's important to note that like we can't take the square of a negative number. So don't. So we are assuming that this is positive when we do this proof. And so we get that root of xy is less than or equal to x plus y over 2, which is why this works. Finicky means that it is like there are details to it, as in we cannot take the square root of the left side in all cases, because if it's negative, we take the square root of a negative number, and that's pretty bad. Okay, sprint question 9. The absolute difference of two positive numbers is 3, and their product is 40. What is their sum? Okay. What do I want to do here? I guess, okay, there is an obvious way, which is just to figure out what the numbers are, which in this case is really doable because they're actually integers, which is really nice. They didn't have to be integers. We're just told that they're positive numbers. But if you want to guess and check, then this would be 8 and 5. However, if they were not nice integers, there is another way to do it, which is, again, manipulating with squares of things. So let us have our numbers be a and b. And we know their difference. We know their difference is a minus b, which is 3. And when we square this, we get a squared plus minus 2ab plus b squared. Now, as we did with our AMGM proof, consider what happens when we take a plus b squared. Then we get a squared plus 2ab plus b squared. And the difference between these two is 4ab, which we know is equal to 160. Yeah. This is a little suspicious. Oh, okay. Everything is fine. Okay. So essentially we have, this is 9. We know the difference between these two expressions is 160, and we're looking for x, where currently here we have x squared. And so we have 9 plus 160 is equal to a plus b squared, which gives us 169 is equal to a plus b squared. And this leads us to, theoretically, two answers. A plus b is equal to 13, and a plus b is equal to negative 13. But out of these two answer choices, we are given that both numbers are positive, which means that it has to be a plus b is equal to 13. Yeah.
Yay. Okay, awesome. 13. Okay. Okay, whoa, there are a lot of words on this question. Okay. Wow. Okay. Nautical dawn is the time in the morning when the center of the sun is 12 degrees below the horizon. Civil dawn is the time in the morning when the center of the sun is 6 degrees below the horizon. I actually never knew that. That's cool. You learn new things from math problems every day. So assuming that one day corresponds to one full rotation, how many minutes pass between nautical dawn and civil dawn? Ooh, okay. I've actually never seen a problem like this before. Maybe it's like really cool. So I'm just gonna draw two circles, and let's say, okay, one is, I don't think I really need the circles. Okay, so we know that in total, one circle has 360 degrees. And one day is 24 hours. So that's some key information I read. And I come up with this because it's saying one day corresponds to one full rotation. So I think rotation, I think of the word degrees. So I thought of 360 degrees, and then I saw one day, which is 24 hours. So now we know nautical dawn is the time when the center of the sun is 12 degrees below. So 12 degrees below is just, it started the first 12 degrees. So the first 12 degrees, I want to figure that out in hours. So I'm going to do 12 degrees divided by 360 degrees. Oh, 360 degrees. Okay. Is basically equal to, what is this? 1 over 30. So basically that means 24 over 30 hours has passed in, what is it? Is it civil or nautical? It's nautical. So this is like basically how much it is for that one. Okay, and then we can similarly do the same thing for civil dawn. Civil dawn, it's 6 degrees below the horizon. 6 over 360 degrees is going to be 1 over 60. And then 160 is going to be basically 24 of 60 hours. So now it's asking us, what does it ask? How many minutes pass between nautical dawn and civil dawn? Okay, so that means we're basically trying to find the difference. I'm going to go to another page. Okay, so 24 over 30 hours and 24 over 60. So let's just remember that. Okay, so 24 over 30 minus 24 over 60 hours. Okay, so then we can just, subtract these. I'm going to first simplify them because these can be simplified by a factor of 4. Okay, so I'm going to do 12 over 15, which is 4 over 5 minus, this can be also factored using 4. So we get 6 over 10. Yeah, 6 over 10, which is 3 over 5. Okay, 3 over 5, which is 1 over 10. No, wait, sorry. This is 5 over 10, right? Wait, did I do something wrong here? What did I do wrong here, y'all? 1 second. 24 over 30. 6.
I think you could have kept the denominator of 60 since we're asked for minutes anyway.
Oh, yeah. Okay. Let's do that. So, okay. 24 over 60. So the answer should be 24 minutes. Sorry, guys. Sometimes it's just subtracting fractions is so hard, Okay. Is it 24? Yes, it's 24 minutes. Okay, awesome. So that's a cool new fact that you learned. 24 minutes pass between nautical dawn and civil dawn. Awesome.
I also saw another really cool solution in chat from Jasper L, who noted that there are 1,440 minutes in a day and 360 degrees in a full rotation. So they found how many minutes it takes to rotate 1 degree. And they found that 1,440 over 360 is equal to 4. So for 1 degree of rotation, it takes 4 minutes. And then we're asked for the difference between 12 degrees below and 6 degrees below. So we're looking for a total turn of 6 degrees. And for each degree, it takes 4 minutes. So we should get 24 minutes in total. I thought that was a really cool approach.
Yeah, I like that a lot. Wow, that's very genius. Awesome job. That was much quicker.
All right. The figure shows a map of all of the sidewalks in Glenn's neighborhood. If all sidewalks intersect at right angles, how many different routes can Glenn take from home to school, traveling only on sidewalks in the shortest possible distance? Hi, Professor Loh. Hello. All right, so we want to take the most efficient route. So that means that if we are trying to get from, where are we going from? from home to school? Wait, this is like not a lot of options, right? Because a lot of these routes are really inefficient. In particular, if we go down here, this is really bad because we're just needlessly adding 3 extra blocks. Or I guess in our case, it'll be 2 extra blocks because this is a root of 3 versus 1. But that means that like this like entire section is just bad. Like for this, we can only take this path here. And then similarly for this upper section, if we turn to go up, that's just bad because then we have to take the other 2 roads. Then we're taking 3 roads in total instead of taking 1 road. So obviously this section is also really, really bad, and we have no choice but to take this path here. Now for these other 2 sections, I don't think that either choice of going either this way or this way is actually bad, because both of them you take 2. You take either 1, 2 or 1, 2. And they're equivalent. Now the bad thing is you can't go backwards, because if you go backwards then you have to go forwards again, and then this adds an extra 2 steps, so you don't want to do that. But as long as we're only going right and down, it should be okay. So that means that when we take the route from home to this point here, we have 2 choices. And then similarly, this school section is just a mirror copy of this one. So we can go down and right, or we can go right and down. This should also give us 2 choices. Now, the question is, what do we do with having all of these choices? I guess one way to deal with this is we can kind of like figure it out, and we can go, oh, we can go, right or down right and then right down, or down right and then down right. And we can just like build this tree. And if we list out all of our options, we have, letters are really hard. What letter does down start with? I think it starts with a D. Okay, down right, and then down right down, and then right down, right, and then right down. So this should give us 4. Now, a slightly quicker way to notice that it's 4 is we have 2 independent choices. As in, when we choose to take a path here, this does not affect our choice here. We can choose either of the 2 here, and then we can independently choose either of the 2 in this section. So what this means is that we can just multiply 2 and 2 together. We have 2 independent events where we can compile either of the 2 here and either of the 2 here. So this should give us 2 times 2 is equal to 4 paths. Yeah.
Yay! Oh, that's good. Okay. I actually managed to come back in, but now I'm curious. Am I all fuzzy or is it actually okay?
You look very sharp.
Oh, wow. Okay, then this sort of works. The fun part about the question you just did is if you forgot whether you're supposed to add the 2's or multiply the 2's, it's still 4, but it's good that you explained it. Okay, I guess since I haven't done any questions in a while, I guess I should try to take the next one. What's this? Okay, Lisa is playing basketball with her friend Leslie. Lisa scores 21 points on 8 successful baskets. Each basket was worth either 2 or 3 points. How many baskets worth 3 points did Lisa make? Okay. So this is one of these questions where it actually is fairly standard, but oftentimes when I think about these, I find it easiest to say, well, let's suppose that they were all 2-point baskets, right? And then you'll see how I chose to do this. You can either say, let's suppose they're all 2-point baskets, or say, let's suppose they're all 3-point baskets. And it turns out if you start by saying, what if they were all 2-point baskets? If they were all 2 points, then how many points would Lisa get altogether? Feel free to type in the chat. It's more fun if people are all participating at the same time. But suppose they were all 2 points, then if you have 8 successful baskets, well, how many points would you get? You'd get 16. Thank you, Bing Wang. So then you do 8 times 2, which is 16 points. But that's not how many points there were. There were 21 points. So then what happens when you upgrade from a 2-point basket to a 3-point basket? I saw that actually, Nivi, you have an idea of using systems of equations. You can do this with systems of equations too. But here's an interesting way of just thinking through it. Is that if they were all 2-point baskets, 16 points. But now every time you upgrade a 2-point basket to a 3-point basket, when you go from a 2 to a 3, that's plus 1 point. So now what you see is, how many times do I need to do this to go from 16 to 21? Well, 21 minus 16 is 5. So I need to do this 5 times. And that's how you get the answer that some people have been typing into the chat, which is 5 of the baskets need to be upgraded from 2 points to 3 points. Notice there's two ways to think of this. You could either start by saying, suppose they were all 3-point baskets. Now, how many downgrades do I get? The reason I like to do this is because I always would make silly mistakes in the past of reporting the wrong answer, in the sense that I got the right thinking, but I answered the wrong question. Like maybe I'd answer how many 2-point baskets there were, and I was supposed to say how many 3-point baskets there were. So I like to do it so that the procedure I'm following is one where if I just follow it, the thing that comes out is the answer, because I might forget to do the last step of like the of it, like subtracting it from 8. But anyway, so I think the answer is 5. Let's see. It is. Okay, I survived one question. With that, I think Pratika, are you next?
Yes, awesome. Okay, so our question here is about snowball fights. Awesome. Okay, so Jesse is making snowballs to have a snowball fight. If Jesse can make 1 snowball every 4 minutes, but 2 snowballs melt every 15 minutes, how long will it take Jesse working continuously to accumulate 21 snowballs? And the question is asking us to round to the nearest number of whole hours. Okay, so right off the bat, I noticed, okay, so I have 4 minutes here and 15 minutes. So I'm thinking like, okay, what's the, common minutes I can get to figure out the net amount of snowballs he makes, right? So I'm like, okay, so he makes 1 snowball every 4 minutes, 2 snowballs every 15 minutes. The LCM of 4 and 15 is going to be 60. So this kind of tells us every 60 minutes, Jesse will make a total of 15 snowballs, but then 2 snowballs melt every 15 minutes. So in that 60-minute time period, that means minus 2 times 4, which is going to be 8 snowballs will disappear from the 15, unfortunately. So it's going to be 15 minus 8, which is 7 snowballs every hour. Okay, so now we know that he'll make 7 snowballs every hour, and it's asking us how long will it take to make 21 snowballs. Okay, so if we know it's 7 every hour, yes, I see so many people in the chat. Okay, so Ling says 3 hours, then Jaden says take the LCM, as I did. Joshua says, personally, I would not take that long. That's such a good point. Here in Canada, we have a lot of snow, and honestly, 21 snowballs in 3 hours, that's just sad right there. Like, come on, you have to do better than that. But yes, okay. Our final answer should be 3 hours. Let's check. Yes, 3 hours. No, Joshua, it's not just you. Trust me. Like any person in this universe won't take that long to make 21 snowballs.
Maybe they're really artsy snowballs, like perfect spheres. Maybe they're building physics models out of them. You never know.
Oh, okay, yeah. You bring up a good point. Okay, I kind of understand Jesse's situation now, I guess.
All right. 7 consecutive odd integers summed to 217. What is the least of the 7 integers? Okay, so I guess if I'm being asked for the least, my gut instinct is to say, okay, A is the smallest one, and then we have A plus 2, and then A plus 4, and so on. But I'm going to do something slightly different. I want to start with the middle one. So I want to have our middle odd integer be x. And the reason why I want this to happen is we have an odd number of odd integers. And what this means is when we do our arithmetic progression in both directions, they will actually cancel out. So we have x plus 2, x plus 4, x plus 6, and then going backwards from our middle number, we have x minus 2, x minus 4, and x minus 6. And we can see how we can pair up these numbers. So we have x minus 6 over here and x plus 6 over here, minus 4 plus 4, minus 2 plus 2, and then x in the middle. And when we sum up all of these numbers, we will get 7x is equal to 217. And the reason why I'm adding 2 here, or why I know to add 2 here, is we are working with consecutive odd integers, which means if we start with a middle odd number, to get to the next consecutive odd integer, or like the next odd integer that exists, I guess. We will have to step over one even integer and then do another add one. So we are adding 2 each time to get to the next odd integer. I see someone has made an observation of, oh shoot, it's odd. Yeah, if you're getting an even answer, it is probably not that. Okay, so now we have 7x is equal to 217. Division. Oh, it's good division. It's good division because this is 210 plus 7. So if we just divide by 7, this should give us 31 for our middle number. And then we're done, right? X is 31. Oh, people are not getting 31. We have selected x as our middle integer, and we are looking for our smallest integer. What is the least of these 7 integers? So we have to take away 6. So if we go back here, I guess we can go through all of them. 29, 27, 25 should be our final answer. Yeah.
Yay! Yeah, that was good. That's a nice way to do these kinds of questions. Okay, I guess I'm next. Ooh, I got some letters. What is this? So, oh, if A, funny symbol B. So this is like an XOR or something. So if A with the symbol B is A squared plus B minus 3A, what is the value of that thing? I guess this is just like, remember to do parentheses first. So let's try plug and chug. Okay, so let's start with inside. 3 and then the thing with -1. So if I look at that, I have to first do the first thing is the A. So that's 3 squared. And then I have plus B, but B is -1, so it's -1. And then minus 3A is minus 3 times 3. Oh, that's neat. So minus 3 times 3, I see canceling. Notice I like to write out the whole thing first before actually doing any of the calculation, because if something cancels, it's easier. So 3 squared and 3 times 3, those are the same. So that's just equal to -1. And then I need to do the whole thing with the 2. Now it's with the -1 and with the 2. Okay, so in that case, what do? I have to have the 2 squared plus the second term, which is -1 in this case, minus 3 times 2. Okay, so this looks like, what do I have? I have 4, and then -1, -6. Actually, the way I'm thinking of this in my head is that if it was 2 times 2, they would perfectly cancel, and it's minus an extra 2. So I just, in my head, the way I'm thinking of this, and you can do math in any way that you like, but I like to think of it this way. It's minus 2 times 2, and then minus another 2. So then we have a cancellation, and I get -3. Is that right? I see some people think it's -3 also, so let's hope we're right. We are! Okay, well, Pratika, on to you.
Oh, y'all, I was muted. That was very silly. Okay, so now we're on to some geometry, my favorite. Okay, so we have in the figure shown, we have PQRS is a rectangle and PQT is an isosceles triangle. We have that the area of pentagon PTQRS is 36 centimeters squared, and we're trying to find the length of PT. Okay, what's really nice about this problem is that we have some lengths in the diagram. So we have that PS is equal to 5 and that PQ is 12. Okay, so I don't want to find the area of that shaded thing because it looks so messy. So let's do some complementary like geometry, you know? Okay, so we have the area of the entire rectangle is going to be 5 times 12, which is 60. And then we can find the area of triangle PQT from here because we'll subtract the ugly shaded area. So 60 minus 36, which is going to be 24. Okay, yay. So now we have the area of PQT. So can someone tell me what's the height of this triangle going to be then? The height of triangle PTQ, given that the base is 12. Let's see. Yes. Okay. Jasper says 4. I like that answer because 12 times the height over 2 should be 24. So then we can solve to get that the height is going to be 4. Cool. Okay. So now we're asked to find the length of PT. So we're trying to find this like hypotenuse here in this right angle. So the reason I can make this a right angle triangle is because it's given the problem that PQT is isosceles. So we draw the altitude from there, and then we can figure out that it's going to form a right angle. So now let's just draw in all the lengths that we know. So this is going to be half the length of 12, which is going to be 6. Okay, and then we know the height is 4. So what's left for us to do? Yes, Pythagorean theorem, Sophia. Awesome. So we just Pythagorean theorem this now. So PT squared, sorry, PT, let's just solve for PT. PT is going to be 4 squared plus 6 squared, the whole square root of that, which is going to be square root of 52. And that's giving me an answer of 2 square root of 13, if I can simplify square roots correctly. Yes, okay, I see Joshua got that as well. Okay, let's see if that's right. Yes, okay, 2 square root of 13. Awesome. Okay, I'll pass it off to Elena.
Lovely. All right. Lauren and Allie are going to race. Lauren runs 0.4 meters per second faster than Allie. If Lauren is going to run 100 meters, okay, wait, I need a diagram. Lauren is going to be green because Lauren sounds like a really green name. Okay. This is Lauren, and she is running 100 meters, and she is running... I don't think we're given Allie's speed at any point, so she's running x plus 0.4 meters per second. Okay, and then we have Allie is also running this race. How many meters ahead of Lauren does Allie need to start in order for both runners to reach the finish line in 20 seconds? Okay, so our finish line will be here. I guess the road does not go all the way there, that's okay. And Allie starts somewhere ahead of here. So she is running some distance, d, this is Allie, and she's running at a speed of x. And what we know is that both of them are running for 20 seconds. So, I mean, one thing we could do is we could try to, like, find each rate or something. Like, we can divide 100 by 20 and then find the rate x and then put that here and then make her run for 20 seconds. And then take the difference between this distance, and that should give us the answer. But a nicer way is to not do that. As in, we're given something really nice. We're given time. And we're actually kind of given the difference between these two distances already in a kind of sneaky way. So let's look at the distance that each one of them covers in 20 seconds. So for, who is this, Lauren, she covers x plus 0.4 times time, so 20. And the reason why this is we have our equation d equals rt, or distance equals rate times time. So when you go at a rate of r for a time t, you will cover rt in total. And then for Allie, the amount she runs will be x times 20. Notice something a little nice here? We have 20x here and 20x here. And we want to find the difference between these two distances, because this is going to be this little segment here. This is how much Allie runs in 20 seconds. This is how much Lauren runs in 20 seconds. So to find the difference, we need to find the difference between the distances. And so what we have here is if we just do the subtraction, we will end up with 0.4 times 20 as this little segment over here. This is 0.4 times 20. Or in other words, it is the difference between their rates times the time they run, which is 20 seconds. The only reason why this works is because they're running for a common time. This is a really handy thing here. I guess you could also do like a similar technique here, but it will not work out as nicely if you don't have the same amount of time. And then we just do the calculation, which is the hard part. 0.4 times 20, this is 4 times 2 is equal to 8. And I think we're asked for distance, yeah. So we should get 8 meters in total. Yeah.
Yeah, very nice. That's a nice trick to be able to realize that you don't need to use all the information in the question. Okay, what's next? Oh, let's do some more questions. So in that case, hang on a second. I will need to adjust something so that Let me pop this in a moment. I'm going to go to our second deck. We have more questions here. Just a second. And this is great. This means that we will get a little bit ahead because the next questions are probably harder. They tend to get harder as you go through the set. Okay, here we go. What's this? Hello again. Here's our next set of questions. Let me make sure that I can see my co-host because sometimes their expression lets me know when I'm doing something fishy. What's this? Okay, we got some quadrilateral. What's the value of x? Oh, okay, cool. This looks like Pythagorean theorem time. So if I go and draw this line between, that's a nice line. Pretend it's straight. Well, then we know that the sum of a squared plus b squared equals that c squared. So let's call this c. So on the one hand, I know that 5 squared plus 5 squared is equal to c squared. But do you know what else is also equal to c squared? There's something else here. There's another right triangle. Anyone see? You can type it into the chat if you want. What squared plus what squared is also c squared. Well, I got some other sides. Okay, that's true. This is 50. Someone simplified this. They said this is 50. That is true. 50 is equal to, well, what else is there? Yes, thank you, Joshua Z. It's x plus 4 whole thing squared plus x squared. X plus 4 whole thing squared plus x squared. Okay, so now let's simplify some of this. So that's going to be, I'm just expanding out x plus 4 whole thing squared. That would be x squared plus 2ab, so that's 2 times 4 times x, plus 4 squared is 16, and I have another x squared. Looks to me like we have a quadratic equation. So if I put that x over there, x squared over there, then I get 50 equals 2x squared plus 8x plus 16. Whenever I get a situation like this, I see that they're all even. I don't like big numbers, so let's divide everything by 2. So then what's left is 25 equals x squared plus 4x plus 8. I realized maybe I should have subtracted 50 across from both sides first. I could have done that. But anyway, it's the same. Now I subtract 25 from both sides, and I get 0 equals x squared plus 4x minus 17. Okay, in that case, I guess we got to do some quadratic equation, don't we? So let's go. I'm just making sure I didn't make a mistake. So I'm going to copy that equation onto the next screen. X squared plus 4x minus 17 equals 0. Okay, so I guess we should just use the quadratic formula. What is that again? Negative b plus or minus square root of b squared, which is 16, minus 4ac. The minus and the minus becomes a plus. 4 times 17, I think it's 68, all divided by 2a. Tell me if I make any mistakes, people in the audience. So, okay, now I guess I have to add numbers. I already see that I can divide a 2 out. So I'm actually going to divide the 2 out of that term, and I'll divide 4 out of each of those because 2 squared is 4, right? So if I divide this thing by 2, I'll get negative 2 plus or minus square root. Now I can divide, I will divide each of those numbers by 4 because the 2 squared becomes 4 inside. So I'll get 4. Oh, why did I even bother to multiply 4 and 17? I didn't have to. I have to divide again. So that was silly. I could have left that at 17. So it looks like what I've got here. And by the way, those of you who are saying you made a silly mistake, I make lots of silly mistakes too. So that's why I'm being kind of slow and just watching the chat to see if you guys can fix me. So negative 2 plus or minus square root of 21. So clearly the answer is x is negative 2 minus the square root of 21, right? Do you guys like that? Oh, I got 2 answers, right? So I should just choose one just for fun. So why is minus 2 minus the square root of 21? What? I like you. You're funny. Well, why is minus a bunch of us liked your comment. Anyway, so why is the negative bad? Yes, because it's negative, because there aren't any negative like distance has to be positive. Oh my gosh, one of you said it's in one of our classes. Okay, right. So x is equal to, it's the plus, minus 2 plus the square root of 21. By the way, I always want to double check and make sure this makes sense. So is that a positive number? How do you know? Actually, how do you guys know this is positive? We know the other one's negative because it's minus, minus. Of course, that's negative. Why is this one positive? Can anyone have a very simple explanation? This is how I double check to make sure I didn't screw up something big time. Joshua Z, yes, module 4 is algebra tools. That's correct. But yeah, great. Square root 21 is bigger than 2. And that's because square root of 4 is equal to 2, and 21 is a lot bigger than 4. So, okay, my answer is going to be root 21 minus 2. Really? What an ugly answer. Let's find out. Woo! Okay, I got it right. Okay, actually, it's quite interesting. They put both of these here. Fun fact, I used to actually help to grade for math counts, and they actually write down all of the different forms of the answer because you're supposed to be able to see all the possibilities there when the person is grading it. So, all right, we survived. In that case, I'll pass it on to Pratika.
Awesome. Okay. So we have a question related to dartboards. So a dartboard is made up of 3 concentric circles as shown with radii 7 inches, 5 inches, and 1 inch. What is the probability that a randomly thrown dart that hits this dartboard will be closer to the circle of radius 5 inches than to either of the other 2 circles? And we're going to express our answer as a common fraction. Okay, so first let's spot which one of these is the 5-inch circle. So I'm going to say it's this one, right? Because it's in the middle number. Okay, so now from here, we have to decide which one will be closer. Okay, so remember, being closer doesn't mean like just the circle itself. So we can have some portion of the circle be in this big, large one with the radii 7 inches, and then a portion in the middle between the one of 1 inch and 5 inch. So let's figure it out. So first what we can do is figure out the difference. So we have the 5-inch circle and the 7-inch circle, right? So the one that's going to be closer is, say, this portion that's right over here in the middle. Oh my God, I can't draw, guys. Okay, that's okay. But so like this little part over here. So it's going to be in the middle. What this basically means, it's 1 inch away from the 5-inch circle because the middle of 5 and 7 is 6 inches. So like any portion in the middle of these 2 circles is going to be closer to the 5-inch circle. Ooh, wow, this is so fun to draw. I love this. Okay. So that's going to be in the middle here. Now we have, what about the 1-inch circle and the 5-inch circle, right? So we should have, it's going to be in the middle between 1 and 5, and that it's going to be 3. So any circle that has radii 3 inches to 5 inches, that's also going to work. So let's color that in. Brings me back to my kindergarten days where I used to color. I love those days. Okay, so let's shade this in. No pi, not pi. Love that comment. Okay. So yes, looks like a solar system. Okay, so now we can figure out this entire yellow, lovely piece of art here. We're going to figure out the area of this. So what we first notice is that the big circle, the big yellow circle, is going to have a radii of 6 inches because it's between the 5 and 7 one. So that's going to have a total area of pi r squared, so 6 squared times pi, which is 36 pi. And now we got to subtract that white part of this part over here. So we see that it's basically like a 3-inch circle. So this is like 1 here, 1 inch here, and then it's going to be the middle of 1 and 5, which we said was 3. So it's going to be, here is going to have length 3, if I'm not mistaken. Let's just make sure that's right. 1, 2, yes, okay, 3. So it's going to be 3 squared pi. That's like that white portion that we're basically subtracting away. And that's going to be 9 pi. Okay, so now we take the big area minus the small area. So 36 pi minus 9 pi. So that's our nice solar system yellow planet over there. Okay, 27 pi. So now it's asking for the probability. Oh, Alex, I like that comment. I miss nap time. Me too. I feel like they should have nap time in high school. But anyways, so we're trying to, for the probability, we want to figure out the total area. Sorry, like the area that works over the total area. So to figure out the total area, we see that the entire dartboard is going to be just a circle with radii 7 inches, which is going to be 7 squared pi, which is the total area, 49 pi. Okay, and then we figured out that 27 pi was the area that works. 49 pi was the total area, so it should be 27 pi over 49 pi, which should be 27 over 49. I see I got the same answer as Bing. That's giving me some reassurance. Let's see if that's right. Oh, that says nothing. Okay, 27 over 49. Yay.
Yay!
Awesome.
Yes, very nice. Okay, that's nice. The pies cancel. It's always nice when that happens. You guys are really hilarious in the chat too, I must say. So I'll actually take the last question. Usually we go to Elena next, but actually the usually was broken because I missed a whole bunch of questions at the beginning trying to get my internet connected. So let's see. Let's see if I can do the last question of tonight. We talked about arithmetic means earlier, maybe or like geometric. There was an arithmetic mean, geometric mean inequality. I think that's what you guys were talking about. I remember hearing Elena mention that. So now if arithmetic mean of two numbers is 7 and geometric mean is 5, what is the sum of the squares? By the way, Sophia has made a really interesting comment that I will agree with. Canceling is really satisfying. Okay, so now let's write down what these mean. So first, oh my gosh, that was not intended to be a pun to say, let's write down what the means mean. So the arithmetic mean of two numbers, that is x plus y divide 2, and that is 7. Okay, now that's going to be interesting because I need the sum of the squares, okay? And I have another equation. The other equation is geometric mean, geometric mean. That's telling us that square root, oh, that's a weird square root sign. Square root of xy is equal to 5. Now, if I want the sum of the squares, that's like x plus y. There's something interesting that happens, which is x plus y doesn't look like it has x plus no, I want the sum of the squares, x squared plus y squared. And I have things like x plus y and I have things like xy. But you see, this feels sort of like x plus y whole thing squared, okay? So what I mean is, let's take the top one. The top one is telling me x plus y over 2 is 7. That's telling me that x plus y is equal to 14. Now, if I want x squared and y squared to appear, let's just square both sides. So if I square both sides of that, then I get x squared plus 2xy plus y squared is equal to 14 squared. If you do a ton of math problems, you know that's 196. If you don't, just multiply. It's fine. And if you multiply, you get 196. All right, I need x squared plus y squared. How do I get rid of the 2xy, everybody? I see some people have answers, but can someone tell me, I see a 2xy that I don't like. Does anyone know a good way to get rid of it? Jasper has got an idea that's floating on its way up. We always can see your comments before they show up on the screen. But the idea is that x times y is equal to 25. So let's subtract 2 of them. Oh, I love subtracting 2 times 25. That's subtracting 50. So x squared plus y squared is 196 minus 50, which is 146. And I hope that is the answer. Yes, and that's correct. And with that, what I'll say is that actually finishes our time today. We don't like insulting math counts because math counts is awesome. And I see that a bunch of us have something that we can put onto the screen. So I'm just going to quickly fast forward to that here too. Yeah, so if you liked what you saw tonight, we're going to be back on again tomorrow night. And also the night after that. So if you like what you saw here, we are very happy to continue to do these questions for the first time with all of you watching and with all of your moral support. I would like to really thank my co-hosts who are, as you can see, spectacular, Pritika and Elena. And well, let's give them a round of applause and we'll see you guys tomorrow. Bye-bye.
Bye.
Bye.
Problems are different tomorrow. We should tell everyone that.